Here is an architectural representation of a distributed app. Each bubble represents a service, and we can see most are Java services and one is Node.js. The size of the bubbles represents the number of flows that go through that service, and the color represents the level of exclusivity of the resources each service relies upon. The dotted lines represent service calls between these services. On the right pane, we can see more information about each service: number of flows, entry points, external or between services, resources, and whether they are exclusive to that service or not. On the left pane, we can open the resources report. We can see vFunction identifies API calls, database calls, Kafka, MongoDB, and Redis. We can focus, for example, on database tables and see that the payment info table is accessed by two services for read and write operations. This is an example of resource exclusivity issue that impacts scalability, resiliency, and engineering velocity. vFunction automatically creates a to-do to address this issue. Let's switch to a different app to see some additional capabilities of vFunction. In order to enable you to troubleshoot architectural issues in your system and shorten troubleshooting time of issues identified by your APM tool, vFunction automatically creates sequence diagrams for all the system's flows. In this example, we see 293 system flows. vFunction automatically creates the sequence diagram of each flow and allows you to export it. Let's focus on two architectural issues. First, focus on circular dependencies, which is an anti-pattern that impacts performance and scalability. We see 7 such flows. In the sequence diagram, we see exactly which services are involved and exactly which call is looping and how many times it is looping. In this example, it is looping 431 times. Second, let's review long flows or multi-hop flows with 3 or more hops. We see there are 9 of those. Again, the sequence diagram clarifies exactly where these occur and what needs to be done. We see the services involved and the calls themselves. Let's switch gears to the architectural governance capabilities of the system. There are already 3 rules in place. Let's add our own. We can decide whether we allow, alert, or require that a certain service or group of services based on tagging call another service or group of services. We can invoke a dry run and validate these rules. We see most actually comply, and for the third that isn't in compliance, the system generates to-dos in order to fix this out-of-compliance issue. This capability allows to enforce and monitor the architecture on an ongoing basis. Lastly, let's review the architectural observability configuration that allows us to monitor the architectural drift of the system. We see the different types of architectural issues that the system identifies: new domains or services, new dependency between domains, resource exclusivity changes, circular flows, multi-hop flows, duplicate services that are better merged. This really allows the user to reduce system complexity and address microservices sprawl. New service dependency, added or removed flow. And lastly, architectural rule violation. The user can configure the data collection that is based on open telemetry tracing data to correlate with each release through CI/CD integration. Unlike APM tools, vFunction focuses on architectural drift, compliance, and technical debt, thereby complementing your APM tools in order to reduce troubleshooting time and get your architecture in check.